Hi, this is Sudip Kumar. I'm data engineering manager at top analytics company. With 10 years of experience in IT and data engineering, I'm having a certification in Azure and Snowflake. I'm specialized in Azure Data Factory, Snowflake, and Databricks, and technologies like Spark, SQL, and Python. I'm having a proven track record of leading successful data modernization projects of Fortune 500. Currently, I'm mentoring at KSR since last 6 months.
Welcome to the new video, and today we are going to talk about what are those top 20 interview questions for the Snowflake profile. So if you are targeting to crack the interview for Snowflake profile, this will really help you to crack the job for Snowflake profile fast. Let's start quick. The question number one that anyone can ask is that what is Snowflake? How it is differ from traditional data warehouses, right? So you can answer simply with the statement that, hey, Snowflake is a cloud-based data warehousing platform, okay? It is not the traditional one. It is stored on cloud, right? Where it has a unique feature. It have separated the storage and the compute resources, which means the storage and compute, they all are independent of each other, but still coupled together, right? They can independently scale. Okay, but this is not the scenario for traditional data warehousing. Okay, and it also can basically use the semi-structured data, store the semi-structured data, which is not the case of traditional. Okay, so these all scenarios, automatic scaling, high concurrency, these are not in traditional warehouses, which is there in the Snowflake. By concurrency means the number of tasks a system can handle. All right, so these all features are available in the Snowflake. That's how it's differ with the traditional data warehouses. Now, another question that interview can ask, which is very common, is that what is the Snowflake architecture? Can you please explain in brief, right? What are its components, right? So you can simply explain the architecture that there are three layers, there are three layers in the architecture. The first one and the bottom one is the data storage layer, database layer, okay? And above that we have a virtual warehouse layer. We call it as a query processing layer. If you go and explain in detail, that database layer is basically where the exactly data is stored, right? In the compressed and the columnar format. Compute or the query processing layer, which is where basically having all the virtual warehouses or compute resources. Okay, it has its own cache, micro partitions, right? Or machines. It's kind of virtual machine, all right, which used to read the data, fetch the data from the database layer. Now, cloud services. What are the components of cloud services? So it includes that infrastructure management, optimize the query, it manages the metadata as well about the data, it manages the security as well, authentication, authorization, right? And the transaction property, all those things are managed with the by this first layer. Okay, that's how the architecture is all about. Okay, another question interviewer can ask is that how basically the compute and the data storage, this layer, right, these two layer, how it's been managed, right, independently, how it's done. So you can say, hey, in the architecture, these two layer we see, these are independent, they are different layer, they are not in single layer, right? That's why compute is in different layer, that's the second layer. The first layer is a storage layer. They are different. Okay, they are not a single instance, so they are decoupled together, but still they are tagged together, they are related, right? But who will manage these two? The cloud services manage all these two. Okay, so what is the benefit of this independently, this decoupling of storage and compute is that it really enables the users to scale them these layers as per the need, as per the workload. As and when number of users are increasing, number of queries are increasing, it can independently scale up, okay, or down based on the need, scale in or out based on the need. All right, it really helps to good flexibility and really helps to save the cost as well. Now, one of the another question that they can ask is that what are micro partitions? So micro partitions are basically the internal small units of storage inside the database layer. So inside this database layer, they are unit of storage. So if you see over here in the physical structure, right? This is the logical structure in the table it will show. In the physical, they are divided into 4 partitions. Okay, you can see first 6 rows are there in single partition. So it's a columnar format, right? So all columns are stored in single partition, correct? You can say another 6 row in another partition. Likewise, They all are divided and they all are ordered as well. As and when the rows are inserted in the table, they are same way micro partitions are being created. Okay, you can see 2, 4, 3, right? So 2, 4, 3. Likewise, they are maintained. So how it can really help you to improve the performance is they are basically organized and ordered data, right? And basically they really help you to fetch the data faster. That's why they really help you to improve the performance. Correct. So they are also very good and help you to in the data pruning and optimizing the access patterns. It means the same thing only. This is organized and ordered data. It's stored in that way only, which really help you to fetch the data faster. Okay. So another question is that what is time travel, right? How you can use it basically, correct? So time travel is that it's basically allow you to access the historical data at any point of time, but with a defined range, defined retention period. So it's basically a feature on Snowflake which really store the data after deletion. Okay. Or even after making any changes in the data. So by default, it's 0 to 90 days. This is a range, but you need to set it. Okay, you can change it. For permanent table, it's 90 days, correct? For transient table, it's 0 days. It will not store any time table for that. Likewise, for temp, it's not applicable. So how we can basically use this time table for the historical data? We can simply use it for the recovery. If you want to recover the data which you might have changed or you want to take a backup, right? So you can do it basically. If let's suppose something deletion happen, one table deleted, one record deleted, one column deleted, all this thing you can recover with the help of time travel. You can go back to that version of the table and you can just create a new table out of it. Okay. So basically that's the main use. Auditing, compliance effort. These are all the use case for the time table. Now, sometime you also get the questions like how Snowflake handles the semi-structured data formats. Okay. Like JSON, XMLs, correct? So you can simply answer, hey, variant data type. That's the answer. Snowflake itself have a data type which is a variant where inside that we can store the data in the form of JSON or XML. Okay. It also help you to query it faster without any transformation. With dot notation, with the semicolon notation, we can simply fetch the nested values or its child items very easily. Okay. This is a very popular question that what is Snowpipe? Okay. So you can simply answer, hey, Snowpipe is another functionality or feature in Snowflake where it provide you to ingest the data continuously, right? It's a kind of ETL pipeline. So it's a kind of, you can say, a real-time thing, automatic loading the data, correct? So that way you can simply say, hey, it's a continuous data ingestion service by the Snowflake where you can set it up to load the data automatically from the source to the Snowflake inside the Snowflake itself, right? And it also can handle the real-time scenario as well. Another question that usually asked is that what is virtual warehouse? How you scale up, how you set it up, how you configure it, right? How you manage it up. So to answer that question, you can say virtual warehouse is one of the component and it's a one of the layer in Snowflake. We can set it up using the configurations in the Snowflake. You can see we can just create the cluster and we can set the size, maximum amount of cluster to keep in a warehouse, scaling policy, auto suspend, right? These all policies, these all things are available in the configurations. So if you see scaling up and scaling down, right? So this means changing the size. Up means size, right? You can change the size from here. Up means increasing the size. Down means decreasing the size. Likewise, scaling out. Scaling out means adding more clusters of same size into the warehouse. You can change that through here. Okay. Maximize cluster. Set the maximum cluster to 10. That's the maximum limit. Okay. So that's how scaling out, adding more clusters. Scaling in means reducing the number of clusters in a warehouse. One of the another question that they can ask with respect to the security is that how a Snowflake ensure the data is secured, right? So you can say there are lots of features available in Snowflake with respect to security. It provides end-to-end encryption, okay, role-based access control, dynamic masking can be done at table level, network policies are enabled, compliance with respect to those HIPAA, GDPR, SOC2 type 2 standards, they are compliant with this, which ensures the data protection as well as the regulatory adherence. This is a very important question from interview's perspective, that how many type of caches it's there in Snowflake. You can simply say Snowflake include three type of caches. Okay, the first is result cache. We call it as a query cache as well, and this is at the cloud service layer. Okay, it's the cloud service layer who maintain this cache. Another is a metadata cache, which is basically including the metadata. Let's say how many records do we have in those in the table, the sum, the count, min, max, all those metadata related thing that is storing in the cache in the cloud service layer. Another is a data cache, or this is basically the cache related to the final layer, related to the second layer in the virtual warehouse. It stores some kind of data within it, as a single virtual warehouse is itself is an instance, a virtual VM, right? So it stores some data in its memory so that the retrieval of the data for the same query and the result can be fetched faster and shown. So cache means storing the data in the memory for the faster retrieval. That's a reason it really helps you to optimize to fetch the data faster and no need to reprocess the data again, right? This is a very important question from security point of view. They can ask what is the significance of roles and privileges in the Snowflake, right? How it uses it. So the answer is Snowflake basically have the functionality called role-based access control, where access on any component or object will be provided based on the role. What are role? It's a kind of responsibilities. Let's suppose I am a data engineer. That is one role. Data engineer could be one role that can be aligned to particular users. And what are privileges? Privileges mean some access on the objects. That data engineer have access on one particular database or any table or view within that database. So they can access only that database, not any other database. Okay, like that, this is implemented. This is a very good question, that what is the Snowflake data sharing feature? Because Snowflake is very good in sharing the data. Okay, so the answer is that Snowflake secure data sharing, it's really a very good feature, and it means like an organization can share the data in real time with other accounts. So the real use case for this is, let's suppose you're working in development environment and you need to fetch or read the data from another account. So environment means account. There could be three accounts under same organizations: dev, QA, and prod. So within a dev, they can access the data, read the data from the prod account. Okay, that's how the data sharing really help us. So the benefit is you no need to have a data duplication. Okay, the data is lying in the prod environment, prod account, but it's been shared. Okay, it's not copied, it's shared. And it really helps to do the collaboration and reduce the storage cost. So there is very advanced level question that they can ask is that how you can optimize the query performance in Snowflake. So the answer to this question will be that optimization for the query performance in Snowflake, it can be achieved through different ways. Let's suppose clustering the data, using mat views, leveraging the caches, result caches, right? And minimizing the data movement. It means filtering the data at early stage within the query. Let's suppose there is a long query. You need to optimize that query. You can just check where exactly, if the filtration is there, just check if that can be done in the initial stage. So that's how even in the Snowflake, it's already have that implementation that it can optimize the query by using the query optimizer. But still, you can looking at the query profile, looking at the time it's taking, right? And each and every step, you can just understand and optimize it. This is a very good question, that how basically Snowflake integrate with the other ETL tool. This integration between the other ETL tool, how it's happened, right? How it support. So the answer is it can easily support this integration with other third-party tools, ETL tools, with using the connectors and drivers, right? Which supports the data integration workflows. It can really easily integrate with Data Factory. Just set up the integration component, set up those connections and configurations, and you can easily load the data from any of the source using Data Factory to the Snowflake. What is mat view in Snowflake? This could be the another question. Okay, so the answer could be mat views in the Snowflake are, it's like any other mat view in any of the database, traditional database. Okay, it behaves like same only. So here the results or the data after calculation, whatever the queries mentioned in the mat view, it's stored physically in the database layer. Okay, so usually the use case for mat view is for doing some complex calculation, driving the KPI, doing some aggregations, some max min, all those complex calculation, that's in the mat view. That is really done already, and data is stored after doing those calculation in the database. Okay, it's usually utilized in the final layer, which is used to be read by the Power BI report or dashboard, that visualization layer. Okay, so it's a very good use case for that. Another question is that what is clustering key? What is the use case of it and the significance in Snowflake? So clustering key, there is no index in Snowflake. Okay, so the clustering key basically help you to define the column on which basis the data within the micropartition, it will be sorted out. Okay, if you don't mention it specifically, it will be sorted out or it will be maintained in the order, that order of ingesting the data. Otherwise, if you mention the cluster key, and it should be the column which is basically mostly used in the where clause while fetching the data. Okay, and also we need to be very careful while creating a clustering key, that if the size is very around TBs, then it's going to be the very good case for enabling the clustering key. Otherwise, you don't see any better performance or query by using this clustering key. Okay.
So another advanced level question is that how Snowflake support the versioning of the data and recovery in case of any changes in the data or deletion, right? So the answer for this question is that there are two features available in the Snowflake. Okay, first is timetable and another is the failsafe. What is timetable? If you see in the picture below, okay, there are three stages you can say for the life cycle of the data. Okay, first is the current data storage, where the data is stored currently, right? And what is this timetable? So this is the timetable period where the data is kept, the versioning is kept for each and every changes in the table for up to the specific number of days, depending on the type of table. For the fail-safe period, fail-safe period is basically for the permanent table, it's 7 days. Okay, 7 days means after this time travel period, again, if you think this time travel period 90 days has been passed away, right? It has been passed. Now that stage is now a fail-safe stage, where data can not be recovered by a user. You need to contact the Snowflake for any help or recovery. That's the failsafe is all about. And in this failsafe period, there is no guarantee by the Snowflake that they will recover it. It's only they'll do their best effort. So another advanced level question is that what is multi-cluster architecture that can handle the concurrent workload? What's its benefit? Okay, so the answer is that multi-cluster architecture in Snowflake, it really allow to have that multiple instances of the warehouse to handle the concurrency. Okay, so how it's done, basically you can see we have a medium warehouse as of now. If we have another instance of medium warehouse, we can call it as a multi-cluster warehouse, which is basically you can see now size is same. So it's just another instance of the medium warehouse. So the benefit of this approach is that it really help you to handle the multiple queries, multiple users, right? And it provide the good performance, right? You can easily scale it as and when needed. If you set the concurrency, the maximum number of cluster to 2, it will scale it from 1 to 2 as the workload increases. Okay, you can set the policy very easily, which kind of policy you want to set to increasing or adding in another instance. Okay, so that's the benefit: high performance, scalability, workload isolation, right? Enabling seamless handling of varying query demands, right? It's all about the workload easily can be managed. This is a very hot topic with respect to data security, that what is data masking and how you can implement it. Okay, you can simply say the data masking in Snowflake is basically masking the few characters of particular text. Let's say we have a column, right? Let's say we have a credit card, right? Or any particular PII information column, right? So in case of credit card, it can mask the last 4 digits, right, of that particular credit card, of that particular whole column itself, right?
It mask in the sense mask with some asterisks, okay, or that is basically the data masking is all about, right? Because we don't want the users who are basically, let's say, data engineer, data analyst, we don't want them to see this data, right, while processing it, while doing some analysis. That's all the benefit of it, and that's how we can implement it. So the thing is, you just need to create a component, create an object, okay, and tag it to that particular column within the table. It will really mask it. The last question in the list of top 20 Snowflake interview question that can be asked is that how basically the data pipeline can be optimized using the Snowflake features. Okay, so you can answer easily that, hey, in the recent project, I have implemented the complete data pipeline end to end, and we can implement the pipeline using Snowpipe by performing continuous data loading. We can use the mat view to do all the pre-computed aggregations. We can apply the clustering key looking at the use case. We can make use of caches. We can optimize the query to have a very good faster query processing. So these all basically query performance, mat view, right, continuous data loading. This all results in the less and reduced data latency and the faster analytics. That's how you can implement the better and the optimized version of the data pipeline.